As someone who has worked with Unreal Engine C++ for over a decade, the experience using generative AI as a whole and then Claude 3.5 Sonnet, it has significantly improved the speed and efficiency of my work by at least 30 times. As an expert in this field, I understand where it is going wrong and then I can ask it to fix its mistake, and even in the rare scenario the code gets too complex for it to fix, then I have to manually fix that, but that is still like 5% of what I used to do maybe 1.5 years ago. In this video, I will demonstrate how you can make the most out of Sonnet to exponentially enhance your workflow and efficiency for your Unreal Engine projects. Today we will explore three distinct areas of development using Unreal C++. The first one is dynamic asteroid generation to test Claude's proficiency in procedural mesh creation, and then we will create a skill tree system with Slate and UMG, and finally we will be developing a crowd simulation to showcase Claude's expertise in creating real-time AI-driven gameplay systems. This comprehensive assessment will highlight Claude's strength in Unreal C++ across various specialized areas that I am very interested in. Like and subscribe to my channel to support my work, and let's get started exploring the capabilities of Claude 3.5 Sonnet. Alright, so this is the home page you are seeing over here. You can start chatting right away. You can also select a model from here. The Claude 3.5 Sonnet is currently the most intelligent one. Now let's create a new project. Here in the project window, all your projects are going to be displayed, and these are the projects you can see I already have created. So let me create a new one. I'm going to make the prompt as descriptive as possible without overwhelming the AI, because if you are adding too many instructions in a single prompt, then it is more likely to give you a generic outline rather than detailed implementation. So I will start with a minimalistic set of instructions so that it is more likely to give me complete code rather than generic overview. Alright, it started to generate the entire actor class. Now we need to see if it works by replicating the classes in our Unreal plugin. Let's copy the entire class, first the header file, and paste it inside our actor class, and I'm going to do the same with the CPP as well. Okay, so now let's fix the issues. First, I need to add the procedural mesh component in the build.cs. There are a few minor issues which are very easy to fix. Of course, if you have basic understandings of how Unreal C++ works, you don't need to ask Claude to fix the minor issues for you. You can do that yourself. Let me run and test this now. I'm going to create a blueprint actor. I will choose asteroid actor as the parent. Let me drag this in the viewport. Okay, so it is coming fairly dark. I think the normals might not be working. I can still view if the geometry is forming correctly in the unlit mode. Okay, so this looks fine. Let me look into the wireframe mode as well. Yeah, the mesh seems to be correctly forming. Even when I am changing the parameters, it looks like it's working, at least in the very basic level. We just need to fix the normal first. So let me send another prompt to Claude explaining the issue I'm facing. Alright, so it is correcting the code, and we are going to now update our code with this corrected version. The normals have been fixed kinda. I can still see the visible artifacts, and when there is no noise applied, you can see it is perfect. Let me also check out some images of the asteroid, because Claude can also detect images. It has vision capabilities, so if it can understand how craters look, then maybe it can create more realistic asteroids. So I added a point in my prompt asking it to look into the reference image and create more realistic outcome for the asteroids. Okay, so the normals look fine. We are not seeing any dark artifacts anymore. Also, these oval shaped marks you're seeing, they're probably what Claude is interpreting as craters. We are going to modify that, but first let me fix the UV because currently the UV looks distorted. So I will ask it to modify the UV, and I will also suggest that this is looking more like rocks and not asteroids, so it can improvise on this. First, let's copy the generate UV function. Here we have some modifications on the crater creation function as well. And now we are also using some layered noise here with frequency and amplitude, kind of like how Perlin-Verley noises work. So we are going to create a few additional variables for the noise parameters. Yeah, the UV seems to be fixed and the noise also looks better. So let's play with the settings now. I will apply some materials on it. Yeah, the UV issues are fixed now. The noise generation is working much better with the introduction of these new variables. But we also need to update the crater creation logic because craters are still not visible. For that, I went back to the coding adventure from Sebastian, where he has explained how he created the moons and planets procedurally. I took a screenshot and I passed it into Claude so that it can understand the image and can implement similar technique in our code as well. As you can see, the craters are generated, but the shape is not quite right, especially these are very hard towards the edges. I can improve the code further. But let's first optimize the code because the process is still very slow. Since I already have a base code structure created, I did not want to continue the previous chat. So I again uploaded the modified file and I started a new chat because the longer the chats are, the faster you exhaust your quota, which basically prevents you from using Claude for at least a few hours. Also for the vertex displacement calculation, I added +1 to the crater height because that was part of the Sebastian's formula but missing from Claude's implementation. Craters are coming correctly in the wireframe mode at least, but when you switch back to the geometry mode, you see a lot of other issues. For example, the normals and UV issues are there. The basic shape is coming correctly, but it is not visually appealing. So I asked Claude to suggest some additional features that we can have, and also I want to make the asteroid look more realistic. It is also giving a lot of suggestions regarding tasks and materials which we don't need because currently we are just focusing on the mesh generation. Alright, so let's update our code and compile. Yeah, so this looks much better. The craters are also properly visible and the noise is also working perfectly. This is also very fast and optimized and working in real times with parameters change. So this concludes a very basic example of procedural mesh generation using Claude 3.5. So this custom asteroid editor is what I ended up designing, and it is currently available on my Patreon. Please download this. You will also get access to the chat community so that you can directly communicate with me if you find any issues, have some queries, or regarding any feature request for this project. So support me by becoming a Patreon member, and let's move on to the next topic. So this is just going to be UI specific. I am not going to add functionalities of those individual skills as of now. We are just focusing on the UI design and the interactions between the skills. Okay, so it gave me a lot of different ideas for dynamic skill sets that are fairly common across different types of games. Among all these different types of design ideas, I'm going to pick the radial skill. And something like this you see in many games including Stellar Blade. Okay, one interesting thing to notice over here is that it is directly adding all the UIs inside the native paint function instead of creating separate widgets for this. Now, if you're not familiar with the Slate architecture, then one thing you should understand here that paint is a built-in event and it is going to run on every frame. But for the sake of this demonstration, I think it is fine. Even if you create a skill system with icons that are not too resource heavy, then I don't think you will even notice any performance hit as well. I wanted to use data asset to populate all the different types of skills. Data asset makes it convenient, but it didn't use the data asset. So I will just ask it to create the data asset instead. Now it created the data asset without having to write the elements in the array separately. We can simply fill the data asset and pass it onto this widget. So it is now expecting the skill tree data asset. Let me create the data asset first. So now we are going to implement all the functionalities in our plugin. So let's create the classes one by one and copy over all the data that was generated by Claude. Here I'm going to create a new widget blueprint. I also need to create the data assets where I'm going to add our data for the skill tree. So let's do that. The type is going to be skill tree data asset. Alright, so let's populate the data. Now let's add our dataset over here. The 5 skills have appeared. Although the thumbnails are not visible because I have not added the thumbnails yet. I will do that in a while. So let's add the blueprint where we are going to test our widget. Yeah, so you can see It is working as expected. Now I will add few more skills. Now I want to make one of the skills dependent on the other skill, and for that we have the connected skills array. Here you can see the two skills are connected via this line. So let's add some icons now for each of the skill widget elements. Now I want to wrap each of the elements with a border that user can customize, and I also want each of the elements to be selected via mouse. So let's see how Claude is going to cater this feature request. Now we have the borders, and also I am able to select the individual skills, and the color is also changing for the selected items. So I want something more similar to the stellar blade design where the connected skills are linearly arranged while the skill belonging to the same level are radially arranged, and we can create a simplified version of that. And to make it understand better, I have also attached the reference image of the kind of design I'm looking for. Yeah, you can see the connected skills are perfectly arranged. See how I can change the level as well as the connected skill sets, and its positions are changing in real time. This can be of course further expanded to create even more additional features, and each of the skills can be mapped with corresponding gameplay ability so that you can also trigger the respective ability when a given skill is selected. Alright, so now let's look into the final example for the day. We are going to create a very basic implementation of crowd simulation in Unreal Engine. To keep it simple, I just want the crowds to move from point A to point B. So let's write the prompt first. This is the crowd manager which we need to place in the viewport directly, and it expects the crowd agent class. Depending on what type of crowd agents you want to spawn, you will create the blueprint classes respectively and add just the class reference, and it's going to be spawning those crowd agents. For now we are going to just keep it simple and add our mannequin character, but later I want to randomize with different types of agents so I can play along with the meta human. So let's implement this first. So I have made this level as a starting point for our crowd simulation, and I also added this navigation mesh which is going to be essential when you are making the crowd move via AI controller. Let's see if Claudia has implemented that. No, it has not. It is directly setting the actor location, which is something that I do not want. I will ask Claudia to implement the built-in AI pathfinding system for moving the agents instead. So meanwhile, let's add our classes. First, I'm going to add the crowd agent. And now we are going to implement the crowd manager actor class. Okay, I think there is already an existing class with the same name. So we are going to just change the name here to something like crowd simulator instead. I am going to now create a couple of blueprints. First one is going to be the crowd agent. Here I will just add the mannequin and the anime blueprint as well. And now we are going to add the crowd simulator actor. This expects the crowd agent class, which is going to be our BP crowd agent. I will simply add it over here. Okay, so I have to call the function spawn crowd in my BP crowd simulator. I want to do it in begin play. Number of agents. You can set this to variable. The spawn location is the actor location itself, and for the destination, we are going to create a target actor and get its location for now. I will place a target point onto the level. This can work as a target actor. So let me add this in our crowd simulator class. Yes, the agents have correctly spawned, but they are not moving, they are standing still. So we are going to see what's wrong, why they are not moving. Yeah, so far so good. The functions are correctly being triggered. So let me ask Claude to solve this issue for me. Just because I'm too freaking lazy to use my brain now that I have this superpower in my possession. Okay, so it doesn't have any clue, so it asked me to add this couple of debug lines. Yeah, the debug lines are correctly showing the destination. Now we just need to figure out why the characters are not moving towards the destination. In the code, I have added several UE log so that I can pinpoint the issue. And as you can see over here, AI controller is coming as null. So we might need to spawn the AI controller first. We are going to add these modifications in our code. Yes, now they are working. The AI controller have spawned. Yeah, I think this is really great as a starting point. Now, obviously, the movement patterns here looks quite repetitive and they don't seem to be bothered about collision avoidance. The movement here is also not very realistic. They are all moving along a single line, especially after they were bypassing an obstacle. We need to have some sort of random offsets here. Also, agents are getting too close to each other. So let's ask Claude to fix all this. So here it is adding some random offsets while setting the destination. Some of the guys are just randomly stopping. It seems that once they have detected an obstacle, they are unable to even continue their movement after the path is cleared. So we are going to fix that now. Here we are also drawing the debug circle to understand how closely they are moving with respect to each other. Yeah, look, they are respecting each other's personal space. But here we have this issue of marching in place when they are finding the obstacle, so we are going to fix that. Here it is calculating the obstacle avoidance direction. When there are any obstacle, the direction it should rotate in order to avoid that obstacle, and it is also drawing the debug directional arrow for that to visually represent the direction of their movement. Alright, so this looks totally cool. Now let's see how they react when they're reaching the obstacle. Here is still a little bit of chaos. They are trying to change the directions to randomly, but overall they still looks great. They are respecting each other's personal space. So they are still not able to stop because their destination have been occupied or blocked by other agents. So what we need to do is have some sort of random destinations and also unique destinations for each and every agent. In the crowd simulator, while we are spawning the agents, we are now setting unique destination to each of them. They are all now stopping their movement at different destination, and this looks more realistic. The only problem we have here is some of the agents not being able to ever stop, and they continue to march in circles even when they have reached near the destination. Let's try and get Claude to fix this issue. I had Claude draw a debug path along the navigation destination so that I can get an idea of the path they are supposed to take. The debug paths for each of the agents is correctly drawn, although they are not updating in real time, but we are kind of getting an idea of if at least the navigation paths are accurately avoiding the obstacles. Most agents have successfully stopped at their destination points, but a few are still taking longer than expected to reach their destination because at times they have taken a longer route after being blocked. While we can keep modifying this plugin and resolve these issues, I'm not going to stretch this any further because we already have a working prototype of the crowd simulation. And realistic crowd simulations, to be honest, is one of the complex tools to develop. Even Unreal's default navigation system is quite limited and they cannot deliver a fully realistic crowd behavior. For that, I may have to implement a custom grid-based pathfinding system. If I'm able to complete this plugin, I might create a detailed tutorial on this for another video. Alright, so this concludes today's video. I hope you found this informative and feel more confident using Claude 3.5 Sonnet for game development and other Unreal Engine projects, especially if you're working with Unreal C++ and have at least a basic understanding of how it functions. Game development is still challenging, particularly for solo developers, but with the power of generative AI like Claude 3.5 and the cutting-edge features that Unreal Engine 5 offers, your workflow can become significantly more efficient. And before we end, I would like to ask for your support. You can become a Patreon member or buy me a coffee through the link in the description. If you have enjoyed the content, your support helps me stay motivated to create more and more tutorials on Unreal Engine. Also, check out my other video on using Claude 3.5 for getting started developing a turn-based game in Unreal Engine. Thanks for watching, and I will see you in the next video.